All right, we're going to talk about linear programming today. So with linear programming, there's a lot of verbiage we have to remember. Okay. So the first is constraints. Constraints are just given limits. So a lot of times these are in the forms of inequalities, which we just got done graphing last time. So it's usually more than multiple inequalities that form a feasible region. Linear programming is a method for finding a maximum or minimum value of some quantity given a set of constraints. Okay, so we're going to use the constraints. We're going to use linear programming in maximizing or minimizing. The feasible region is the region that contains all the points that satisfy all the constraints. So it's usually going to be some kind of enclosed area. The objective function is the model that is being maximized or minimized. Usually it's going to be p of xy, it's going to be something along that. The vertex principle. So the maximum or minimum will occur at a vertex or a vertice. Okay, so we're going to test all of our vertices in our objective function. So here's our list of constraints here. Here's our objective function. So we're going to maximize 2x plus y. We're going to actually graph these. We're going to find our feasible region. We're going to find all our vertices, and then we're going to plug them in here. Well, I'm going to solve these for y first. So here I get y is less than or equal to negative 1/2 x plus 5/2. Here I have y is greater than or equal to x minus 2. And these are just my x and y axis. So I'm going to start here by graphing these two linear equations and finding where they're equal. Okay, so I'm going to graph this first one, 1, 2, so 2.5. Okay, I'm going to go down, so down 1 over 2, down 1 over 2, down 1 over 2. And I have a nice solid line, so hopefully I'm there. Okay, and now I'm going to graph this bottom one here. So I'm going to go down 2, and then up 1 over 1, up 1 over 1, up 1 over 1. Solid. And then x is greater than 0, so I'm going to be on the right of my y-axis. Y is greater than 0, I'm going to be above the x-axis. So I'm actually in this little region right here. Okay, so I already know this corner right here. It's 0, 0. I probably should know this corner here because it is 0 and then 5/2. I know this corner because it is 2, 0. Now, how do I find this corner? Well, if you go back to systems of equations, we want to find where these two are equal. So what I'm going to do is these are both equal to y, so I'm going to set them equal to each other. So I have x minus 2 is equal to negative 1/2 x plus 5/2. If you don't like working with halves, you can easily get rid of those by multiplying everything by 2. I'm just going to add a 1/2 x here, add a 1/2 x. I'm going to add 2, add 2. So this is going to give me 3/2 x equals, well, 5/2 plus 2. And remember, 2 is 4/2. So this gives me 9/2. I'm now going to multiply this by 2/3. So that cancels out. That gives me 1, 3. So x is equal to 3. Okay, pretty close there. Now I need to find my my y. So my y is equal to 3 minus 2, which is 1. So this point is the point 3, 1. So this is working back to previous knowledge that we used when we use systems of equations. Now, a lot of times I will write p of 0, 0, p of 0, 5/2, p of 2, 0, and then p of 3, 1. And I will test all of them just to see which is the max min. So this is 2 times 0 plus 0, which is 0. 2 times 0 plus 5 halves, which is 5 halves. And then I have 2 times 2 plus 0, which is 4. And then I have 3 times 2 plus 1, which is 6 plus 1, which is 7. So our max is 3, 1. Okay? So you want to make sure that you graph all of your constraints. I would not necessarily use my graph here in this value because this looks like about 2.9 and 1.1. So make sure these are precise. You're going to have to go back and use systems of equations and solving it to find these. Okay?